Okay, we're going to look at this problem, and it's autotrader.com would like to estimate the number of years owners keep the cars that they purchase as a new vehicle. The following data shows the age of 7 vehicles that were sold for the first time by their owners. So here are the ages of the 7 vehicles, and we only have a sample. And we want to find the 90% confidence interval that estimates the average age of cars sold for the first time. So we do not have the population standard deviation, and I just want to look at that real quick. So when we don't know the population standard deviation and all we have is a sample, we are actually going to use the sample standard deviation in place of the population. So when you're calculating your standard error of the mean, instead of it being the population standard deviation, you can see that we're going to use S in the place of it. So it's still a standard deviation, it's just the sample. So we are not using the Z, the normal distribution here. We're going to use T. So when you don't know the population standard deviation, you're going to replace it with S, and you're going to use the T distribution. So the T distribution is a table, but instead of using N, you're going to use what we call degrees of freedom. So you're going to take the sample size and subtract 1. So if your sample size was 20, you would look up 19 on the table for degrees of freedom. Ours is 7, so we will be using 6. It kind of works the same way though. The area under the curve is going to be 1, and the bigger the sample gets, the more it's going to look like a normal distribution. Here's the formula. It should look very familiar, except instead of Z, we're going to use T. So let's look at our problem. We have to know a few things to calculate a confidence interval. One of the first things you see in your formula here is X bar, which is the mean. So we need to calculate the mean. You can do this in your calculator. You can do this in Excel. One of the first things we did in this class, besides vocabulary, was calculate the mean. 4, 12, 3, 10, 7, 4, 5. Make sure I have that right. 4, 12, 3, 10, 7, 1, 2, 3, 4, 5, 6, 7. Okay, so what we can do here in Excel real quick is get the average, which is the mean. So the mean is 6.42. Let's round up to 6.43 here. So we know X bar is 6.43. And I do not like the way that looks. So let me write that again. It's hard to write on this sometimes. Now we have to know the standard deviation of the population, and we learned how to do that, and it may be a little blurry for you of how to calculate it, but just for this purpose we are going to do, and I believe it is this one. We'll go with that and see what happens. And we get 3.41 for our standard deviation. So let's write that number down. So we have X and we have S, and we know N. Our sample size is 7. So now we're getting ready to calculate our confidence interval because we have what we need to get started. Okay, so for our confidence intervals, we have an upper. Let's do the upper first. So our formula up here, and let's see if I can zoom in on it, is x bar plus our t-value times our standard error. So let's go ahead and get the standard error of the mean, which is s divided by the square root of n. So let's go over here and do the standard error of the mean, which is s divided by the square root of n. So that would be 3.41 divided by the square root of 7. So let's do that on a calculator real quick. 3.41 divided by square root of 7 is, I'm going to round to the second decimal place. So you would get 1.29. So now we know we're going to do our x bar plus or minus our t-value times our standard error of our mean. So we know our x bar, which is our mean, is 6.43 plus, now here's where we have to go look up our t-value. We have a 90% confidence interval. So if you go to your appendix and you find the t-distribution, then you kind of have to scroll until you get to it. The first one is, it takes a minute to scroll. You can also look online for these if that's a little bit easier. This is the standard, so we're gonna keep on going here. Okay, here's the t. So I think we said 90%. Yes, 90%, and our degrees of freedom is n minus 1, so 7 minus 1 would be 6 degrees of freedom, and a 90% confidence interval. You have to know those two things. So here's 6, and then 90% would be 1.943. So t is 1.943, and our standard error, which is this right here, 1.29. Now I'm going to show you something here, because sometimes they ask you for the margin of error, and that is how much you're adding and subtracting from the mean. So if you want to know your margin of error, it is just your t-score, or sometimes it's your z-score, times your standard error of your mean. So let's just see what that is, and let's keep that separate before we add it to the mean. 1.943 times 1.29. So your margin of error is 2.51. That is the number that you're going to add and the number you're going to subtract from the mean. So let's see what we get when we add and subtract 6.43 plus 2.51. You would get 8.94. And then 6.43 minus 2.51, and you would get 3. You would get 3.92. And so your 90% confidence interval would be from 3.92 to 8.94. And what that means is we are 90% confident that the population mean is between 3.92 and 8.94. So the 90% sure that the population mean, or the population average of the age of the cars of owners, is between 3.92 and 8.94. And I can say that the age of my car is probably somewhere in between there. And that is how you calculate the confidence interval for a t-distribution. Let me know if you have any questions.